Today we're taking a look at section 7.7 on quadratic equations and applications. We begin with the definition of a quadratic equation. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equal to 0, where a is not equal to 0. So what that's telling us is that we must have an x squared term. Okay, so how do we go about solving quadratic formula or a quadratic equation? We have several different ways we can solve a quadratic equation, and depending on the format that the equation is in, I may use one method on one and a different method on another. And for example, the very first one is what's called the zero factor property. And that is, if a times b is equal to 0, then we know that either a or b or both must be equal to 0. So if we have a quadratic equation that has been factored into two binomial factors and they're multiplied to give us 0, what we know is one of those two factors has to be 0 for that product to be 0. And so if we add 4 to both sides of this equation, we get x is equal to 4. If we subtract 7 from both sides of this equation, we get x is equal to -7. So that's how we end up with two solutions, either a +4 or a -7. So basically we're just looking to see what makes each factor equal to 0. This is one of my preferred methods for solving. If I can factor the quadratic very often and it's equal to 0, very often that's what I'll do. The square root property, if k is greater than or equal to 0, so we have a positive number or 0, then the solutions of x squared equal to k are x equals plus or minus k. So let's take a look at an example. Suppose we're looking at x squared is equal to 9. What they're saying is we can take the square root of both sides, and when we do so, we insert plus or minus, and of course the square root of 9 is 3. So our x would be plus or minus 3. Now notice we could have solved this by factoring, simply by subtracting the 9 from both sides. And then we notice this is a difference of squares. So we could have solved it by that first method. Okay, but if it's set up like this very often, it's easiest just to take the square root of both sides. Okay, third one, and probably the one students remember most often, is when we have a quadratic of the form ax squared plus bx plus c equal to 0. We come up with two solutions. X is equal to minus b plus the square root of b squared minus 4ac all over 2a. And this part inside here, that's called the discriminant. The part inside the radical. And what we know is if b squared minus 4ac is positive, we get two real solutions to the quadratic. If b squared minus 4ac equals 0, we get one real solution. And actually it's called a double root because you're adding 0 and subtracting 0. So you get the same number twice. If b squared minus 4ac is less than 0, we have no real solutions. We do have complex solutions, but no real ones. And I believe in our book that they don't talk about the complex solutions. No, they don't. I didn't think so. Okay, so let's see if I can find an equation here we can solve using the quadratic formula. X squared plus 2x minus 5 is equal to 0. Okay, so notice on this one you also have to have it in the form where it's equal to 0, just like we did when we wanted to solve by factoring. So our A is 1, our B is 2, and our C, notice, is a negative 5. So x will be the opposite of B, so the opposite of 2 would be negative 2, plus or minus the square root of B squared. 2 squared is 4, minus 4 times 1 times negative 5, all over 2 times 1, which will be 2. So that's going to be negative 2 plus or minus the square root. This is going to give us a 24, positive 20 there, plus 4, over 2. Now, you may have forgotten how to simplify a radical. I'm going to factor this down into primes. Okay, 24 is 12. This is how I'm coming up with this. Although at this time I have done it so many times I know exactly what it is. Okay, divided by 2. Anytime you have a pair, you can bring one out. Plus or minus 2 square root of 2 times 3 would be 6. So we end up with negative 1 plus or minus square root of 6. Okay, so those are the 3 basic methods we're using in this particular section. And we also have some application problems, and I'll do some of those in the sample problems.